We're talking about codominance, incomplete dominance, and multiple alleles, the basics. So the first thing we're going to talk about is what exactly is multiple alleles. Well, multiple alleles simply means that there are more than two alleles for a trait in a population. The key is population. Right? There are still only two alleles to a gene, but instead of having just being tall or short, you can be tall, short, and medium. So in blood, for example, you have the A allele, the B allele, and the O allele. Does not mean that you have all three in your body. It just means that in a population, right, there's someone that has A blood, B blood, and O blood. You only have two alleles for blood. Now, if we look at codominance, now codominance simply means that both alleles contribute equally to the phenotype. So, for example, in blood, you have an A allele and the B allele contributing equal amounts to give you the AB blood type. Now with black fur here, we have black fur and tan fur. As you can see, they have a capital H, so they're dominant, and you have white fur as a lowercase h. So as you can see, we're bringing in the multiple alleles. We have three different possibilities here. We have a parent here that's big HB, little h, for that has black fur, and big HT, little h for tan fur. Now when we fill out the Punnett Square, as you can see, I started to do this already. It's just like any other type of Punnett Square, where I take and I bring down the h's and the little h's. Now if we take a look at the upper left corner here, right here, you'll notice that there's two capital H's. Well, if I just left it like this, would I know what kind of fur it was? Was it black fur? Was it tan fur? Well, they're both dominant, so how would I know? Well, that's why we use these exponents. All right, so that's why we use the B's and the H's here to help show, what dominant allele I'm dealing with. So in this case, we bring our B and our T across. All right, now bring our B, just like you normally would. So now if I take a look at the genotypic ratio here, let's move this, slide this over a little bit. So looking at the genotypic ratio, I've got 1 HB, HT. I have 1 HBH, 1 HTH, to 1 little h, little h. So what does that mean phenotypic-wise? Well, let's take a look here. Well, here we have the BHT is codominant. They have two dominant alleles, so that's 1 black and tan. Okay. HB, little h. Well, big H represents a dominant allele, so big HB is black, so that means there's 1 black. Big HT, little h. Well, big H is a dominant allele, so it masks the little h. That's 1 tan. And then last but not least, you have 1 little h, which represents white. So there you go. Pretty straightforward, just like we've done in the past. The key here is that when you have two alleles that are dominant, they both show up equally. Well, now what about incomplete dominance? Well, incomplete dominance is when one allele is not completely dominant over the other. Well, here we have an example. We have H big R equals red, and H big W is white. So we're having two parents here, HR, all right, and homozygous dominant white. So when I do this, just like before, we have WR, 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 WR. So what is the genotype here? Well, there's 1 H to 0. All right, what about the phenotypes? Well, if red is dominant and white is dominant, and we're dealing with something that's incomplete, well, halfway between red and white, oh, somebody's time to go. Halfway between red and white is, that's right, pink. So incomplete dominance is halfway in between both of them. So if I have something that's black, I have something that's white, halfway in between is
Brendan Johnston,
great.
Burke,
Good luck.
Andrew Benton,